Hello, I want to talk to you about Node.js or Node. This is an open source and cross-platform runtime environment for executing JavaScript code outside of a browser. Quite often we use this platform to build backend services, also called APIs or application programming interfaces. These are the services that power our client applications like a web app or mobile app. These applications are simply what the user sees and interacts with, but they need to talk to some services sitting on the server or in the cloud to store data, send emails or push notifications, kick off workflows, and so on. Node is ideal for building highly scalable, data-intensive, and real-time back-end services that power these client applications. Now, we can ask, what's so special about Node? There are other tools and frameworks for building backend services like .NET, Rails, Django, and so on. Well, Node is easy to get started, and it can be used for prototyping and agile development. But also it can be used for building super fast and highly scalable services. It's used in production by large companies such as PayPal, Netflix, Uber, Walmart, and so on. In fact, PayPal rebuilt one of their Java and Spring-based application with Node, and it found that Node application was built twice faster with fewer people, in 33% fewer lines of code, in 40% fewer files, and more importantly, they double the number of requests served per second, while decreasing average response time by 35%. Node is an excellent choice for building highly scalable services. Another reason for using Node is that in Node we use JavaScript. If you're a front-end developer and if you know JavaScript, you can reuse your JavaScript skills and transition to a full-stack developer to get better job with better pay. And you don't have to learn any new programming language. Also, because you can use JavaScript on the front end and in the back end, your source code will be cleaner and more consistent. You will use the same naming conventions, the same tools, and the same best practices. And finally, another reason for using Node is that it has the largest ecosystem of open source libraries available to you. So you can add any features or building blocks to your application and focus on the core of your project. And now we are going to look at architecture of Node. So Node is runtime environment for executing JavaScript code. Well, before Node we use JavaScript only to build applications that run inside of a browser. And every browser has what we call JavaScript engine. This engine takes our JavaScript code and converts it to a code that a computer can understand. For example, Microsoft Edge uses Chakra, Firefox uses SpiderMonkey, and Google Chrome uses V8 JavaScript engine. So browser provides us environment for our JavaScript code. and we have the window and document objects. These objects allow us to work with the environment in which our JavaScript code is running. And up to 2009, the only way to execute JavaScript code was inside of a web browser. And in 2009, Ryan Doll, the creator of Node.js, came up with a brilliant idea. He thought that it would be great execute JavaScript code outside of a web browser. So he took the Google's V8 engine and embedded it inside C++ program and called the program Node. Similar to a browser, Node is runtime environment for JavaScript code. It contains a JavaScript that can it contains JavaScript engine that can execute our code, and it also has certain objects that provide an environment for JavaScript. But these objects are different from those objects we have in browsers. For example, we don't have document and window objects, but instead we have other objects that give us more interesting capabilities. For example, we can work with the file system, we can listen for requests on a given port, and so on. So, in essence, Node is a program that includes JavaScript engine plus some additional modules that give us capabilities not available inside browsers. We can work with the file system, with the network, and so on. Both Chrome and Node share the same JavaScript engine, but they provide us different runtime environments for JavaScript. So next we are going to look at how Node works. Node applications are highly scalable, and this is because of non-blocking or asynchronous architecture of Node. Single thread is used to handle multiple requests. In contrast to this architecture, we have blocking or synchronous architecture, and that's how applications that built with frameworks like .NET or Rails work by default and out of the box. So when we receive a thread, when we receive a request on our server, one thread is allocated to handle that request. As part of handling that request, it can be likely that we need to query a database. And as we know, sometimes it can take a little time until the result is ready. So when the database is executing our JavaScript, or when the database is executing our query, that thread is sitting there waiting, and we need new thread to handle new client. And imagine if we have a large number of concurrent clients, at some point our threads can run out, and new clients have to wait until those threads are available. Or if we don't want them to wait, we need to add more hardware. So with this kind of architecture, we are not utilizing our resources effectively, and this is the problem of this kind of architecture. And yes, so that's how applications built with frameworks like .NET work by default. Of course, in .NET it's possible to use asynchronous architecture, but you will have to do extra work for that. In contrast, Node applications are asynchronous by default, so we don't have to do anything extra. In Node, we have single thread to handle all the requests. And when request arrives, our single thread is allocated to handle that request. And if we need to query a database, our thread doesn't have to wait for the database to return the data. It can be used for serving another client. And when the database is when database prepares the result, it puts message in what we call event queue, and Node application is continuously monitoring this queue in the background. When Node finds an event in this queue, it will take it out and process it. And this kind of architecture makes Node ideal for building applications that include lots of disk or network access. And we can serve more clients without the need to throw in more hardware. That's why Node applications are highly scalable. In contrast, Node shouldn't be used for building CPU-intensive applications like a video encoding application or image manipulation. Because in this kind of applications we have lots of operations that should be done by CPU and few operations that touch our file system or the network. Since Node applications are single-threaded, while performing the calculations to serve one client, other clients have to wait. And that's why Node shouldn't be used for CPU-intensive applications. It should only be used for building real-time and data-intensive applications. So that's all what I had to say, and thank you for listening. Bye.